Okay, so this is the real numbers and number lines notes. Our learning criteria for today is that you're going to be able to find square roots and classify real numbers. So this lesson is broken up into two different sections. The first section is finding square roots. The second section is going to be classifying real numbers, which I'll explain more what that means in a minute. So some general information. The square root symbol is called a radical. So this symbol right here is called a radical. The number inside of the radical is called the radicand. Okay? Those are just some key. So in the future when you hear something like what is the radicand in this number or in this expression, then you know it's the number inside the radical, because we're going to be using these words. So you need to make sure that you understand them. All right, so finding square roots. So a radical or square root means to find two equal factors of a number. So two numbers that multiply together that are the same number. Okay. The radical is an operational symbol that goes away once you answer the question. It is not in the answer. So once you find the square root, it goes away. Okay? The one thing that we want to always remember is that for the most part, there's going to be two answers. Okay? So what is a number that can be multiplied by itself to equal 49? Yes, 7. Okay? What is another number? 7 times 7 is 49. What about negative 7 times negative 7? Is that 49? Yeah. So whenever we have a positive square root, so there's not a negative sign on the outside, we're always going to have two answers. We're going to have the positive and the negative answer. This is called the plus or minus symbol, and it would be 7. So if that's the case here, I have 100. What's the square root of 100? 10, but it's not just 10. It's positive and negative 10. So we do plus or minus 10. 0 is a special case. Is there a negative 0? No, it's just 0. So the square root of 0 is 0. Right. If there's a negative sign on the outside, it's looking for the negative answer. Okay? So what's the square root of 4? 2, but we're looking for the negative answer, so it's negative 2. Okay? What about 1? Square root of 1. 1 and negative 1. So it equals plus or minus 1. So here, 441. That's negative 21 because we're looking for the negative answer. So the plus and minus means it's plus 7 and negative 7. Okay? Whenever we have a fraction, it's the same as the square root of 1 over the square root of 9. Okay? It's the same thing. So what's the square root of 1? 1. And what's the square root of 9? 3. And then we always have the positive and the negative answer. Okay? Unless it's negative out front. Okay, you should make sure you're writing this down on your notes. Okay, how about 4? What's the square root of 4? 2. Square root of 25? And it's negative because there's a negative out front. So it's the same. You just break it apart. You do them separately. Okay? How about a negative on the inside? Are there two of the same numbers that can be multiplied together to equal a negative number? Can you multiply 4 times 4 to equal negative 16? Can you multiply negative 4 times negative 4 to equal negative 16? No. So whenever you cannot have a negative sign inside the radicand. It means that it is no solution. It's not 0. It's no solution. Okay? What about the square root of 20? Is it a perfect square? No, but we have a lovely function in our calculator that we can use. It's not asking us to round, or not asking us to round to an integer, so it's going to be plus or minus, and you should get 4.747, about. And on the next slide, I'm going to show you guys how to estimate where we're not using a calculator, okay? Because on your EOC, there will be a day without a calculator, and this would be a perfect example of a day that you wouldn't need a calculator for. All right. So this says estimate the root. Round to the nearest integer. An integer is a counting number, or counting numbers and their opposites. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So 41. What two perfect squares is 41 in between? For example, the square root of 36 and 49. Okay, it's asking us to round to the nearest integer. So what is the square root of 36? 6, plus or minus 6, but that's fine. And what's the square root of 49? 7, plus or minus. So, I know that my answer, I'm looking for an integer, so it's either going to be plus or minus 6 or plus or minus 7, but I don't know which one, because I don't know which one's closer to. So I'm going to find out which one it's closer to. How many away is 36 to 41? 5. 5. How many away is 41 to 49? 8. So it's closer to 6. So if I was rounding this to the nearest integer, it would be plus or minus 6. Because it's closer to 6. Okay? Okay, what two square roots is 78 in between? 64 and 81. And what is the square root of 64? 8 and square root of 9. Okay, so now I'm going to do the same thing. How many away is 78 from 64? 14. And how many is 78 from 81? 3. So which one is it closer? Is it closer to 8 or closer to 9? 9. So it's going to be plus or minus 9. So it's closer to 9. All right. This one we're just going to have a negative answer, but we can still find it the same exact way. So which two perfect squares is 119 in between? Yes. 100 and 100 is 10. What's 11? 121. So this would be 10, and this one would be 11. We're doing negative and negative. Okay, so how many away is 100 from 119? 19. How many is 119 from 121? 2. So which one is it closer to? Is it closer to negative 10 or negative 11? Negative 11, because it's closer. So my answer would be negative 11. Right. A square has an area of 98 meters square. What is the length of the side? So this one is a little bit different. Because we're looking for length, we're not going to have a negative and a positive. And when we round up on length, if we were trying to do length, no, we would always round down on length. Okay? So we round down on length. So I just need to find which square root is closest to 98, that's smaller. It would be 100 would be 598. 100 would be my larger. So what's my smaller? 81. I'm not going to do the rule where we find the difference because I always round down. So my answer is going to be 9 meters. Okay? I wouldn't round up on length because then you'd go too far. Okay, so comparing and ordering numbers. You would first want to find the decimal value of each number to help you compare. You want them all as decimals because it's easier to compare decimals. Then remember that the larger the negative, the smaller it is. Okay, because we're thinking about a number line. Okay. So let's look at this. What is 5.5 as a decimal? 5.5, right? And then this one I'm going to let you guys use a calculator on because it's not a perfect square. So 27, you're going to type in your calculator, then you can hit the square root button, which is below the tan button. 5.19. 196. 5.2. I'm rounding. 5.196 makes the 9 go up, and then that round up the 9 to 2. Okay. So which one is larger? My 5.5 or my 5.2? 5.5. So this would be greater than. Okay. Negative 22 divided by 25. I need you guys to type that in your calculator. I don't have one. Negative 0.88, and it doesn't keep going, right? And then this one is negative 0.8 repeating. So this means this one goes on forever. So this one would be further down on my number line. So which one is larger? The 88, because it's ends. Okay, it doesn't keep going on forever. It's smaller technically on the, it's closer to 0, which means it's larger. Okay, we're going to order these from least to greatest. The key thing here is we want to put them into decimals. However, when we list them out, you want to list them as their original form. We're not listing out the decimals, or else you're going to lose points on your test. Okay? So you first turn them into decimals and then write them out in their original form. So 1/2 would be 0.5. We have negative 2. What is the square root of 5? 2.23. And negative 7 divided by 4? And we have 2.4. Okay, so what is my least or my smallest number? Negative 2. Okay, then, yes, negative 1.75, but I'm not writing negative 1.75. I'm writing negative 7 over 4, okay? Because you're writing it in the form that they gave it to you. Okay, I've used those two numbers. Now what am I left with? I don't have any more negatives, so now I'm going to the positive, so I'm going to 1/2. Then I am going to the square root of 5, and then 2.4. Okay? Okay. How about negative 13 divided by 6? Negative 2.16, then the 6 is repeating? Yeah. Okay. How about the square root of 3? And then it's negative. $1.73. And what about 9 divided by 4 negative? 2.25? Okay, so from least to greatest. Somebody tell me which one's least. Yes, but what was it originally? Negative 9 over 4. Remember, we have to write it. Okay, what is my next number? Negative 13 over 6. How about the next one? Negative 2.1. And then what is my last one? Negative the square root of 3. Remember, we don't write it as the decimal, we write it as what it was originally. Okay, and if you want, you can mark them off as you use them. That's what I like to do, because then it helps me out with knowing what I've already used. Can you erase? All right. Okay, so the real number system. So all of these numbers, both rational and irrational, are real numbers, okay? So rational numbers include everything that's within inside here. So integers are rational, whole numbers are rational, and natural numbers are rational numbers. Rational numbers are numbers that can be put as a ratio or a fraction. They are numbers that end. They don't keep going on forever. Or if they do go on forever, they repeat. Okay? Integers, we talked about this earlier, are counting numbers and their opposites. So like 1, 2, 3, 4, and negative 1, negative 2, negative 3, and negative 4. Whole numbers are counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but it includes 0. Natural numbers are counting numbers, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Irrational numbers are numbers that go on forever but do not repeat. Okay? Or numbers that you cannot put in a fraction. Okay? So, let's classify negative 1. We need to say every single thing that it could be. Yes.
Integer.
It is an integer. What else is it? What else is on the outside of integer? Rational. And then what is all of these numbers? What are they? Real. So negative 1 is an integer. It's rational and it's real. Okay? Yes. Do you want to see what the next one is?
Irrational.
It is irrational because if you find the square root, it's not a perfect square. If it's not a perfect square, it's irrational. Okay? So it's irrational. But all of them are real. Okay? So we have some statements here that we're going to be telling if they're true or false. So all positive numbers are integers. Is that true?
No.
Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah? Yeah, that's true. All natural numbers are rational numbers. Natural numbers are counting numbers. Yes, true. I can't spell. All decimals are rational numbers. False. No, because remember we have some that repeat that go on forever that aren't. Irrational numbers are not real numbers. False. Irrational numbers are still real. They're just not rational. Okay, so